Hello everyone, today we're going to be taking another look at Three.JS and seeing how hard it is to create a Minecraft style terrain inside of a Ruby on Rails application. This is mostly just to see how these things work and not necessarily because your production code needs a Minecraft clone in it. It's just always fun to see how to accomplish these things. So to get started, we're going to have to add a couple flags to our Rails new command. So we're going to start with the Rails new video, and then we're going to do a -j of ESBuild and a -c of Bootstrap. So to get started, we're going to have to do our Rails G controller pages home, and then we're going to have to generate our stimulus controller, which we can do with a Rails G stimulus. We'll just call it the game controller so that we have some JavaScript to work with. And then we're going to have to add a couple of yarn packages. These are going to be for our Three.JS. We're going to have to add a open-simplex-noise package and a seed random package. And the reason why we're going with the seed random instead of the random is because we want the randomness to be the same every time we refresh. So you can see in the scene whenever, I guess you can't see it anymore, but you'll have to trust me. Whenever I refresh, the trees are in the same location. So to do this, we're going to go ahead and open up our Visual Studio Code, and we'll take a look at what needs to be done. Now the first thing is, because we're using the ESBuild and the foreman gem, we're going to have to come into the gem file because I'm still on Ruby 3.2 and it's still not quite working for me. I do have to do a gem for foreman with a GitHub of the foreman repo, which hopefully GitHub Copilot figures out for me, and then I can run a bundle in our terminal to install that. We can now come into our app, views, pages, and our home page. And in here, all we want to do is set up our stimulus controller, similar to this, where we have a empty div with some data, where the data is the controller and points to the game controller we created, which of course is our JavaScript controller that's over here in app JavaScript controllers game controller. So this is pretty much where all of our logic's going to live. The only other thing we really want to do is come into our config and our routes.rb, change the get to a root and the slash to a hash, just so that we have a home page to work with. Now with all of that done, we can run a bin/dev command just like that, and that should hopefully start our server and allow us to go to localhost port 3000, where we should see hopefully nothing right now. Of course, my Brave browser is just refusing to work with me today, so I'm going to have to open up a new tab until eventually it allows me to go to localhost port 3000. So now if I hit Control-Shift-I, we can open up our web dev tools, and we should be good to go. And we can put some text on the page just to make sure this is the right page. If we refresh, there's our test. Okay, cool. So that's working. Now let's make sure our JavaScript's working. Let's come into our game controller and just do a quick console.log. We'll take whatever GitHub Copilot suggests for us. There we go. So we have our controller. Cool. All right. So first things first, we need to import all of the stuff we're going to be using, which of course with JavaScript is always going to be an absolute bundle of joy. Orbit controls is our controller, so that lets us move in the scene. The open simplex noise lets us generate a procedural noise where every time you put a coordinate in, it'll be adjusted up and down relative to the coordinate next to it is probably the easiest way to say it. So you get like a smooth rolling hill pattern when you pass in x equals 1, x equals 2, x equals 3, etc. Instead of like a pure random where x might be 1, and then or if x is 1, you might get like the value of 10, and if x is 2, you might get the value of 100, which causes like a steep cliff for no reason. And if x is 3, it's back down to 0. So we want something a bit smoother, so we go with the simplex noise. And then we have our seed random, which just lets us set up a random seed. So to get started, we'll come in here and we'll create a set seed of 1337. You can set this however you'd like so that the player can randomize it. We're then going to create a call to a method that we create down here to initialize the scene. Let me make sure I grab the right code here. Initializing the scene just sets the scene to be a new 3 scene. Now, the code I'm going to be pasting in is kind of hacked together just because I kind of threw this together this morning. I was short on ideas. But we're going to init the scene. We're then going to initialize the camera. And to do that, we pass in an init camera. In here, we say the camera has a couple different options. If we hover over this, we can see The first option is the FOV, which is set to 95. Second is the aspect ratio, which we get by calculating with the window inner width and the window inner height. I learned that one from the Fireship.io tutorial on Three.JS. Then we pass in the near clipping and the far clipping. This is just like how close you get to an object before you can't see it anymore, and how far away from an object you can be before you can't see it anymore. So like if you get super close to a wall in games, sometimes the wall kind of disappears. That's what this number's for. And if you get super far away from stuff, it disappears. That's what this number's for. All right, so that's our camera and our scene accounted for. What's next on our list? Next, we want to set a renderer. This is essentially going to create a canvas if you don't have a canvas defined. And in our case, we don't have a canvas defined, so this is just going to create one, and then it's going to add it to the screen, just like this. So we come over here and we refresh, and we scroll up. We'll first of all see that 3 is not defined. That's totally fine. But if we come up here, we can click on something, hopefully, and we probably won't see it because we should actually define 3. So to define the Three.JS, we do need one more import. I guess I missed this one, where we import star as 3 from the 3 package. If we do that and we refresh, and now if we hover over it, you'll see that the entire screen is the canvas because we passed in the aspect ratio of the inner width and the inner height. So that's how we're doing that. The next step is to come down here and create a Three.JS geometry, which we can do right here. Then we want to create our materials, and this works similar to any other game engine you've used where you create some materials. It's actually pretty easy to work with once you wrap your head around it. Basically, we're going to paste all of this in. We'll just focus on one of the materials first. So you create a material. It's created with a new 3 mesh standard material. You can pass in a color and an emissive. If you have a directional light or something, you need it to have an emissive color so that it emits that color. I kind of just make the color and the emissive color match. That way, if there is no light in the scene, I still have a color. You set the wireframe to false because you don't want to see the wireframe. You set the flat shading to false because you don't want flat shading. And then you set the emissive intensity. If it's set to 1, it's going to glow like you have a light bulb in the scene. If it's set to 0, it's not going to emit anything. So you kind of want to find the middle ground. So for most of these, I set it to just be some color that's vaguely similar to what the word is. So grass is kind of green, dirt is kind of brown, stone is kind of gray. The tree trunk is also kind of brown. You'll notice it's very, it is actually the same as the dirt because I guess I Googled the same hex code. And then the only one here with a trick is the leaves, which has a opacity of 0.5 and a transparency of true. So this one's a transparent material. The rest of these are just regular materials. So that's how we're creating all of those materials. And next we can take a look at the lighting. This is also not too difficult to understand. All we do is we create a directional light, we make it a white light, we set the intensity to 1, kind of just play around with the value until you find something that works for you. And then the other thing we do is we set the position to be 1 up. In this coordinate plane, you kind of have like a x-axis, and then your y-axis is your vertical. Y is like your up and your down, and then your up and your down. And then your Z is like your left and your right, if you want to look at it like that. I know it's not the best graph, but in this case, our X is our left and right. This is our top, or our up and down, and this is like our top and bottom or something. So we set it to be up a little bit just so it hits everything, and then we set the scene to have the directional light added to it. If we grab all of this and we refresh, you'll see that nothing really changes. To actually navigate the scene, let's start by adding a color to the scene. How about that? We'll add a background color to the scene that is sort of like a bluish sky color. And we won't actually see anything yet because we need to add the camera. So we'll come down here, we'll say the camera needs to be, I guess, in the animate loop. So let's create the animate loop real quick. In the animate, we can do this, and then at the bottom of our connect method, we want to call the animate loop. So really the only thing the animate loop is going to be responsible for is updating the renderer for the camera, the controller, and requesting a new animation frame. So we have our camera already initialized in the init camera. All we need to do is add the controller for it. which thankfully we can do real quick just by coming up here above the animate. We'll just say this.controls is equal to a new orbital controls, where we pass in the camera that we initialize down here, and then we pass in the renderer, which is just our canvas. We then set the camera to have a position, which is just in the XY coordinate plane where we want to start from. And we start from 45, 45, 45, which is pretty far away, but it allows us to be back a little bit. Once we do that, we can see we get the blue background. At this point, we are good to start creating our terrain. So to do this, we just create a call to an innocent little create terrain method. The reason why I say innocent and little is because it's deceptive how much logic is hidden inside of this create terrain. The last thing we can do is we can create another material. I'm actually going to copy this down into our materials list. This is just going to be for our world origin. So we'll come up here and we'll set this to have an origin of 0, 0, 0. Now the create cube method is something that we have to actually create. So we'll just come down here below our create materials, which I'm going to collapse for now. Link to all of this code will be in the video description if you need to take another peek at it. That way you don't have to like stop and restart the video. Although that's good for the YouTube algorithm, it's not good for your brain cells, so I'm going to spare you from that. So all we're doing with the create cube is we're taking in an X, a Y, and a Z and a material. And then in this, you are then saying for the cube, create a new mesh that takes in the geometry, which is your geometry that you created up here. It's just a box geometry. It takes that in, and then it takes in the material. It sets a position, and then it gives it a name. This is sort of important, so later, if we want to remove blocks, we can use that name. And then it just returns the cube. So the cube gets returned from here, and then it gets added to the scene because it's inside of this scene.add list. If we do this and we come up here, we can refresh. Let me comment out the terrain real quick so we can at least see our origin. And now if we scroll in, we can see we have a cube add 0, 0, 0. So that's pretty neat. Unfortunately, that's really not that interesting. So we're going to change this to be up like, I don't know, 30 blocks for now. And then if we refresh and we come down to our create terrain again and we do this, there we go. So now it's up a bit, and that'll sort of be our indicator for if our terrain is sort of making sense for what we're doing. So for creating the actual terrain, there's a couple things that go into that one. So we're going to come down here below our create cube, and we're going to call a create terrain method. This doesn't take in any arguments, but it does a whole bunch of stuff. So I'm going to hit F11 because we're going to be in here for a minute. We're going to paste in this code. First, we create a 3 group. This allows us to add blocks to the group, and then we can add all of the blocks in the group to the scene at the same time. We then give it the seed, which we don't need because we refactored that earlier to just have the seed up top in the connect method. We give it a frequency and an amplitude. A height is, so the way you can think about it is your frequency is how frequent you want your like peaks and valleys in the noise to be. So as this number gets smaller, the peaks and valleys sort of smooth out because they're further and further apart. So you just get rolling hills instead. Your amplitude is how high those hills go. So the higher the number, the bigger the hill. The smaller the number, the flatter the terrain. Your height and your width are your actual grid size. So your width is like your X and your Z, and your height is your Y. And what we do here is we set an amplitude, which is our max block height, and then we set the actual height of the grid to be that times 2, for example. Now this really isn't necessary because we're not creating any of the blocks above the amplitudes 50. But if you had like an actual grid where a player could add blocks, you wouldn't want to have the mountains probably go all the way up to the world height or like the ground. You'd want the player to have some amount on top of that to build on. So this is just sort of like building up for that. Then we have our noise where we just pass in our seed for both of those. And then we create a pseudo random number generator, which we call PRNG, by calling seed random and passing in this.seed. All right, so now for the for loops. Of course, if you know anything about runtime, this is probably going to be scary for you, but unfortunately, when you're creating a 3-dimensional grid, you need to create a 3-dimensional for loop. So the way that this one's going to work is we loop through our width from 0 to width, our height from y is equal to 0 to y is less than height times 2, except our height is already our amplitude times 2, so this is unnecessary. That was a bug on my part. So we're going all the way up to our height, and then we're going all the way up to our width again. This is a bit backwards, but I prefer to just keep the y in its proper position whenever the coordinates are y indexed. It's just personal preference. Now for our noise, we create a value from our noise 2D. This is what's going to be generating the number we then do our looping for to like create the terrain. And what we do is we apply the frequency to both of the coordinates, and then we multiply that by the amplitude. Now, what this allows you to do is as this number grows towards 1, you're going to get more and more jittery terrain. As this number grows towards like whatever your world height is, you're going to get like more and more of your terrain filled up with blocks, basically. Now, to calculate something that we can use in terms of our height, what we do is we just say value is equal to y minus the value. So as the height increases, we're going to take off the value. And then at a certain point, if we're above that value, we want to change what our blocks are. So as long as we're below the value of 20, so anything below y equals 20, what we want to do is call that create cube method. And then we pass in the x, the y, and the z, and we set this to be a stone material. We then call terrain.add. So everything up until, I guess, y equals 19 is going to be a stone block. So if we do this and we come over here and we refresh, I don't think we're adding the terrain yet. So what we're going to do is in our this.create terrain call up here, we create the terrain, but what we probably want to do after we create the terrain is add the terrain. So how do we do that? Well, we can come down here, and at the bottom of our create terrain, we can, right here maybe, just say this.scene.add, oops, that's a spoiler, add the terrain. If we do that, we come over here, we refresh, we'll see we have this cool little terrain here that already looks a bit like a Minecraft terrain. Now, some of the more familiar viewers are probably going to point this out, so I might as well address it now. We are just creating blocks for this. In an ideal world, you would want to go through and you would want to add the vertices for these blocks, which would just be your coordinates. And then you would want to check if the block next to it is an air block. And if it is, then you should render the face or, add the 2 triangles for those 4 vertices. And if it's not a air block, let's say it's another solid block, so like this block and this block are touching, we don't want to render the face between the 2 because the player can't see it and we're just creating unnecessary triangles, which is why if I zoom in here, you see all of this gray because everything inside of here is still creating these triangles, which is really, really bad for performance. But this is sort of like a dry run just at testing this. That's more like if you're trying to create an optimized system. Okay, but that's our value here. Now let's create something where if we are within 3 blocks of this value, we add the dirt material. And you can see Copilot already knows what we're doing here. Then finally, if we are within the 2 blocks of the 25th block, which is going to be our grass, which is really only a 1 block difference, we then add our grass material. If we do all of this, we come over here and we refresh. You can now see we get the stone to dirt to grass gradient. So that's pretty cool. Now in terms of our trees, all we really have to do here is just call our PRNG. We get a random number between 0 and 1. And if that number is greater than 0.99, which is like such a minuscule chance, we're going to go ahead and try to create a tree from this root. So to create the tree from the root, we can come down here, create another method for this. Again, you don't need the trees. Sometimes people ask like, how do I do X, Y, or Z? And I kind of try and cover like the stuff that I don't personally see a lot of tutorials for, which in hindsight is always pretty easy to implement. But like when you're first facing the question, it's kind of scary. So all this is going to do is create the same shaped tree every time. But what we do is we loop through from I equals 1 to I equals 4. We start at 1 because we don't want to replace the grass block we're putting the tree on. So we go up 1 and then we put a trunk. We create a cube, we pass in the trunk material. So we create 4 trunks. Then we loop from I equals -1 to I equals 2 to create some leaves. We then loop from J equals -1 to 2, etc., etc. So we're creating sort of like a little box around the tree. And then we just add a cube to that location and we offset it by 4. So that is essentially how we're creating our trees. So once we do this, we have our trees added to our terrain here. If we come over here and we refresh, you can see we're getting a whole bunch of trees here that kind of look a little bit strange. So the reason for this is because our loop here for our trees is adding this for all of the blocks in the height. What we want to do is we want to add this into the top layer here. So once we're at the grass layer, or even more ideally, what you could do is you could create a separate layer here where it's like Y26 or something. And oops, that's not what I wanted to do. And now if we come over here and we refresh, you'll see that the trees are only added to that grass layer. We get the tree shape there, and they are a little bit transparent in the leaves, just like that. So that's pretty cool. Now the next thing to cover here, because we now have our trees, is kind of the only other thing that we haven't really talked about before on this channel, because I have talked about noise before. But how do we add something like a little ravine like we had in that demo scene? Well, the little ravine is a little bit tricky. What we do is we come down to the bottom of these for loops. We can collapse these. And what we do in here is, and actually ideally what you would do is you would take this and you would extract this into its own function, but you get the idea. What we do is we create a call to a new method, which we call tunneled terrain. Now we create this tunneled terrain and we're actually going to pass this into our scene add. So we're going to pass in our terrain, and then we're going to get back a new terrain that we just assigned to tunneled terrain. We then pass in the width, the height, and the width of this terrain as the X, Y, and Z limits or bounds. We pass in our frequency, our amplitude, and our terrain. So we can come down to the bottom here below our create terrain method, and we can create these tunnels. So we'll just go ahead and paste this in. Now this looks a little bit scary, but bear with me. So we have our let noise 3D equals a make noise. We're actually not even using our height, so you can probably refactor that. I had some leftover debugging code where I was trying to figure out the range of the noise. We then create a for loop where we go from I equals 0 to like our width is -3, for example. This allows us to have a border on one side of the chunk and no border on the other. We then go from j equals 3 to the amplitude. This allows us to have a bottom of our ravine. And then we do the same thing for the k here, and we go to the depth of -3. We then create another noise. This time we're using a 3D noise instead of a 2D noise. The only real difference there is it takes into consideration the z coordinate or the y coordinate, depending on how you have this set up. And we do the same thing. We multiply each by the frequency, then we multiply it by the amplitude. The values we get back kind of vary. So what I did here is I just chose like 2 within this range to then create a cube, where we try to get a cube by doing terrain.getObjectByName, which is possible because we assigned all of them to have names in our create cube method. So that's why we did that. So that allows us to access this cube. Then if this cube exists, this is an important check because it probably won't exist, we can then call terrain.removeCube. And then after we do all of that, we can come down here, get rid of our little debug statements, and just return the terrain. Now, if we do this, we come over here and we refresh. You can now see we get this cool little ravine that sort of goes through this chunk. And it is a little bit hard-coded in the sense that what we did here was we went from 0 to -3. What you would probably want to do is make sure that you're giving it cause for termination and you're not hard-coding it like this instead. So maybe if your value for like one of the other coordinates is within a specific range, you terminate the ravine or something. But I still thought this was a pretty cool use case. And overall, I think this is a pretty cool use case of the Three.JS framework in general, because it does show you sort of like what you're capable of doing with a small little terrain like this. And although it's not super performant right now, you can crank the numbers up a little bit if you're so inclined. Maybe you want to make this a 50 by 50 terrain, and this will take a second to load. But once you start refreshing, it should hopefully load in. All right, so here is our mega terrain. This is probably going to be pretty laggy. It's actually not that bad, but you get the idea. So here you can see the difference between the hard-coded values with the cutoff and the values where we allowed it to carve out the terrain a little bit. But yeah, hopefully this was a interesting exercise. Hopefully this was, I don't know, got your brain juices flowing. And hopefully I will see you in the next video.